So today we're taking a look at the 5.1 and 5.2 material. The overall idea is that we're going to be working with solving systems of equations. This is actually stuff that we have been doing up to this point in time, but we're now going to actually formalize it and give it some actual names and whatnot that we have from here. So our main definition for solving a system of equations, and primarily a solution to a system of equations. So the solution to a system of equations is where the two lines intersect, or where they cross each other. We want to determine this exact point on the two graphs. So as of now, what we're going to cover today, we're going to go through the two methods that we have to do this. There is a third, but that comes in 5.3. So our first method is graphically, that's using the 5.1 material, and algebraically, which is the 5.2 material. So we're going to go through both of these methods, at least in their generalities, and then I'm going to show the algebraic method first in examples, and I'll show you guys graphically what that looks like afterwards. So graphically, again, we want to graph the two equations given to us on a set of axes. So this is the chapter 4 material. So if you're told, determine the solution to the system of equations, meaning where do these things cross, graphically, you need to set up the set of axes, you need to label the set of axes, you need to scale them, define the positive and negative directions. You need to do all of that if you're doing it by hand. Then we need to graph the two equations, and we have multiple methods to go through and make that happen. So whichever one you are most comfortable with, you're welcome to use, but we need to graph those two equations on a set of axes, however we can make that happen. From there, we can determine by inspection, which means we just look at the graph or the two graphs and see what's been given to us. Let me see, where do these two lines intersect or cross each other? And then we write that point down as the final answer. Now, the warning that goes along with this graphical method, if you have to guess at this point, this method is not recommended, and you should solve it algebraically to get a more exact answer. And the main idea behind this is if you were looking at something and saying, okay, well, this point looks like it could be at, I'm making numbers up here, it could be at the point 2, maybe it's for an x value, and maybe the y value is, maybe it's a 1.4, 1.5, it's kind of sort of partway between two of the major axes lines on our graph. If you have to guess at it, I wouldn't recommend using the graphical method. That's where we want to get as exact as we possibly can, and we want to use the algebraic method that we're about to go through. Now, there are some instances on the homework, and I think there's one or two of these, where they're going to ask you to approximate an answer by looking at a graph and determining what the solution is. And there's a big difference between approximate an answer and find an exact answer. If we're just looking for an approximate, yeah, we're probably fine using a graph. But if we want an exact answer, there's nothing wrong with starting with a graph, but if you can't get exact with it, absolutely go to the algebraic method to find the answer. Okay? So we're going to go through the algebraic method. We'll actually work through a couple of these, and I'll show you guys the visual of what we find algebraically and how that turns out, what that looks like graphically. I think the algebraic method is a bit more intensive. It requires more steps, as we'll see. There we go. And then we can go through what that looks like visually and graphically from there. So algebraically solving a system of equations, we've actually been doing this a fair amount of the time up till now, but now we're going to formalize it and refer to this method as the substitution method. So starting with this, we're going to be given two equations. They're both going to be linear equations. They could be written in any number of forms, and we'll see a couple of those in the examples that we're working with. So again, linear equations, we have that, we have that slope-intercept form. We have the point-slope form. We have the two forms for our vertical lines, for a horizontal line and a vertical line. And then we have what's referred to as standard form. And we've seen that one show up quite a bit. It's when both of the variables are on one side of our equation, and we have a number on the other side. And it's just the different ways that we can and will be seeing linear equations showing up in these problems. But again, with all of these, if we're solving these algebraically, we will be given, or we will need to create, two linear equations for ourselves. In creating linear equations, we have our process or our different ways of going about doing that from the homework 2 material. But after we've done that, we have our substitution method to go through and solve these things. So, first step in this process, solve one of the equations for either variable. It does not matter which one you choose, either will work. So that means you can solve for assuming x and y are only two variables, you could solve for x or y in either the first or the second equation. It does not matter. You just need to pick one and move forward with it. And I feel like I'm going to, if it hasn't gotten annoying right now of how many times I'm going to be saying that, pick one and move forward with it, that's because we're starting to get into a part with math where you have lots of options available to you. And again, you just need to pick one of your options and then move forward with it to find your answer. So we have solved one of the equations for either of the variables. Now we're going to substitute the expression from step 1, where we solve for one of those, into the other equation for the corresponding variable. So if I solved my first equation for y, then I'm going to plug that expression that I found, y equals a bunch of stuff, in for that variable in the second equation that we have there. And then we are going to solve the resulting equation that shows up at that point in time. We'll work that out. We'll find x equals blah, something. Substitute the result from step 3, that numerical answer, x equals something, into one of the original equations to find the other variable. So I solve for my x value, great. I'm going to substitute that into one of my equations, and I'm going to find the y value that corresponds with it. So I have my x value, I have my y value, and then I want to write the solution as an ordered pair, my x and y. Now we can check our answers. Our step 6, you can kind of put some air quotes around this. It is optional. It's recommended if you're a little shaky on your confidence with your answer. But you can check the solution in both original equations by plugging them in for x and y. And then if both sides of the equal sign are the exact same, you have the correct answer, you're good to go. Now, it should be noted that as we are following this process, we have 3 different potential answers that can come out of this. And I believe we saw this at the very beginning of this quarter when we were working with, we were classifying or finding classifications of equations or solutions to equations. We can either have instances where we have 2 lines that are parallel to one another, which means there will be no solution as the 2 lines will never intersect. We could have the instance where the 2 lines are actually the exact same line, which means there will be infinite solutions because they intersect each other at all points. And remember, our kind of layman's terms definition for intersecting is where they cross each other. So if they cross each other at all points, well, then I have an infinite number of solutions or an infinite number of places where they cross over there. Or the instance where the 2 lines are neither parallel nor are they the same line, which means there will be a single solution to the system of equations. And this is our most common occurrence that we have showing up. We go through our process, we find x equals a number, we find y equals a number, and we have our final solution there. Okay. Now we have 4 examples that we're going to go through, and I'm going to go through these things graphically, and then we're going to go through what these things are going to look like, or actually we're going to go through these algebraically first, I should say, and then we'll go through them graphically. I think the algebraic method is a little bit more time intensive and I want to give us time to see that, and then we'll go with what these things look like graphically, using some technology for that. So I'm going to jump us over to our Blackboard, but these are the 4 examples that we're going to be referencing over there. Okay, so determine, or overall, stuff we're being asked to do here. Oops. So we're being asked to determine the solution to the system of equations by substitution. So it means we're using the substitution method to make this happen. Now, example 1, again, we have been given 2 equations here. It may be the case that we might need to create our 2 equations depending on the problem. But in this instance, we have been given our 2 equations. Now, my recommendation, label these for yourselves, equation 1 and equation 2. Okay. Now, I'm referring back to and just reading off of our process. Solve one of the equations for either variable. It does not matter which one you choose, either will work. So we have the choice of either rewriting equation 1 or equation 2 in terms of either x or y. Essentially, solve the first equation for x or y, or solve the second equation for x or y. It does not matter which one you choose. You just need to pick one and move forward with it. So I am going to choose, for the sake of this instance, I'm going to choose the first equation, and I'm going to solve it for x. So I want x equals something. And the reason I'm choosing x in my first equation is because if I want to get that all by itself, it's as simple as subtracting 3y from both sides of the equation. And I get x is equal to negative 3y plus 10. So I've subtracted 3y from both sides of my first equation, gets me here. Better arrow in there. Okay. Now from here, step 2. Substitute the expression from step 1 into the other equation for the corresponding variable. So I just found x equals negative 3y plus 10. I'm now going to substitute that in for x in my second equation. And my recommendation for you when you do this, write out the original equation first. And then in your next line below that, then write in the substituted values. Again, this method of organizing it is kind of your call, but I find this to be very helpful with keeping, for me at least, keeping my work in line so I know what I'm substituting and where I'm substituting it. You could even go so far as to maybe underline it or put a box around the thing you're going to substitute. It's your call. And now from here, nothing fancy. Step 3, solve the resulting equation. And now I'm solving this thing for y. So everything that we've been doing, I think all the way back from chapter 2 even. So 4 is distributing through. So getting to that there. Better. Got that. Combine like terms on the left-hand side. I'm getting, what's it going to be, negative 11y. Then I'm subtracting 40 from both sides. Again, a lot of this that we're doing right now should be review. And then I'm dividing both sides by negative 11. Okay, y is equal to 2. Okay, negative divided by negative is a positive, so we got that there. So I have my y value of 2. Now I'm coming back up here, and we're told, we're looking at step 4, substitute the result from step 3, which is that value we just found, into one of the original equations to find the other variable. So we just found our y value, and now we can substitute that in for y in either of our two original equations. We do not want to use a modified equation, because what if we made a mistake there? We'd basically be giving ourselves a false confirmation that we have the correct answer. So substitute it back into either of the two original equations that we have been given. Again, does not matter which one you choose. You just need to pick one and move forward with it. So I'm going to choose this. Well, we'll use the first equation because why not? So I'm writing out my original equation that I'm using. Equals 10. We found a y value of 2, so that's what I'm substituting in. And now from here, I'm just solving for x. I'm finding that x is equal to 4. So my final answer at this point in time, we're told in step 5, write the solution as an ordered pair, which means when you are being asked to solve this equate for the solution, you need to write out your answer as an ordered pair for 2. So we're finding each part individually, but we're bringing it all together as, as an ordered pair for our final answer. Now, if you want to go through and check your work, and this is kind of an optional step, but if you're a little shaky on your confidence with how you went through and solved this thing, this is perfectly valid to do. It's also perfectly valid to do on the test, I should mention. So if you're kind of wondering, I don't know if I got the right answer or not, you can go through and check your answer, or check your work and realize, oh, I'm going to get full credits for or full points for this thing, or not, or maybe I made a mistake somewhere. So I'm going to check my answer in each of my two original problems. Again, original problems we've been given. So my first equation is that there. And now I'm substituting in the x and the y value accordingly. And I highly recommend to everyone when you are substituting values in, whether they are positive or negative, I highly recommend you always substitute in inside of parentheses. And as we go through and do that, we solve this first one. We say, okay, well, great. This is a solution to our first equation. Fantastic. Now we need to check it with this answer with our other equation. And our other equation is 4x plus y equals 18. So I'm going to write out the equation. Better 4. Again, substitute in the x and the y value accordingly. And again, when you substitute them in, put them inside of parentheses. Simplify the left-hand side down. Right-hand side is already fully simplified. 18 equals 18. Fantastic. This thing is a solution to this equation, and we know it beyond any kind of a shadow of a doubt. So we have our final answer. So this check part that we have in here that we just did, again, this is optional. You are not required to do this, but I would highly recommend at least giving it a shot if you're a little shaky, a little hesitant on going through and having your final answer. Okay, nothing wrong with it. So let's move on to our second example that we have here. So our second example, we have been given the equation 2x plus, or negative 2x plus y is equal to negative 11. And our other equation is x plus 3y is equal to 9. So we have our first equation, we have our second equation. Got those there. So again, just like we did in our process, or following our process, I should say, we're solving one of the equations for either variable. Our previous one, we solved our first equation for a variable, and our example we have here, I'm going to solve the second equation for a variable. And again, it's whenever you're going through this, it's your call as to which variable and which equation you want to use. It does not matter which one you choose. Saying it again, you just need to pick one and then move forward with it. So I'm going to choose to solve for x in my second equation. So when I do that, I want to get x equals, and the best way to do that is just to subtract 3y from both sides of the equation. I get to that there. Now, working with our second step, substitute the expression from step 1 into the other equation for the corresponding variable. So I'm plugging this into my first equation for x. So again, let's get that x looking a bit better. There we go. So again, I'm writing out my original equation 1. You can maybe put a box around or an underline or something about that x, whatever is going to help you organize and realize that's where I'm going to be doing my substitution. So I substitute that in. Suddenly now I have one equation that just has y's in it, and from here, step 3, solve the resulting equation. So now we're going back to, again, methods that we've been using up to this point in time. This should all be a review for everyone at this point. Or let's put it this way, this should be nothing new to us. At least with the method that we're using to solve this. So 7y is equal to, and add those together, I'm going to get 7. Divide both sides by 7. We're getting that y is equal, y is equal to 1. $18 is positive. No, we have a negative times a positive gives us a negative. Make sure you are carrying those signs through if you're doing the distributive property. That is not going away. So we just found our y value. Step 4 in our process, substitute the result from step 3, this y equals 1, into one of the original equations to find the other variable. So we have our y value, we need to find our x value. And I'm going to choose the first equation. And again, I recommend you write out the equation you're going to use and then substitute things in. So I found a y value of 1. So I'm substituting that in. And now I'm solving for 2x. I don't need that 1 on that side, so I'm subtracting 1 from both sides. Oops. Get that there. Divide both sides by -2. And we're getting x is equal to 6. So again, we are being asked to find the solution to this system of equations, which means we need everything brought together as an ordered pair final answer. If you do not do that, you will be losing points. So our final answer of 6-1. And you can go through and do the check if you would like to, the exact same way that we did with our previous example. I will let you guys do that on your own. This is the correct answer to this equation, or this system of equations, but I will let you guys do the check on your own time if you would like to. I do want to get through our next two examples and then show you guys these equations graphically as well, what these look like graphically. So moving on to example 3. So we've been given, similar to our previous one, we have our two equations. Our first equation given to us is 5x minus 2y is equal to negative 10. Our second equation is y equals 5 over 2x. So we have our first equation and we have our second equation. Okay, so once again, we're following our process. Solve one of the equations for either variable. Doesn't matter which one we choose, either will work. So as we're looking at the system of equations we have here, our second equation is already solved for one of the variables. We already have a y equals something. It could alternatively be written as x equals something, and either way, one of the equations has been solved for one of the variables, which means part of our work is already done for us. So, with that in mind, we would be able to substitute that in for y in our first equation, which means our first step in this process has already been done for us. Now our process for substituting is the exact same thing that we did with our previous two examples. I would highly recommend you continue to write out the original equation, optionally highlight the thing that you were going to substitute in for. Again, that part's your call, but at least write out the original equation. And then actually write in the thing you're substituting. Do not do any kind of cancellation, do not do any kind of computation. Just write out the substituted values in there in your first line of work. A lot of people do not do that, and they lose a lot of points because of that. So now from here, we have 5x minus 2 times the quantity 5 over 2x. We have a 2 written out front, and we have a 2 down below with our fraction. Remember that any whole number is implied to be over 1. So with a 2 on top and a 2 down below, those are going to cancel and become 1s. So really I have 5x minus 1 times 5x. So really I have 5x minus 5x is equal to negative 10. Make that a bit clearer here. Better negative. There we go. Simplify the left-hand side down, and we get 0 is equal to negative 10. And this is not a true statement. This is impossible. So at this point in time, if we get to a stage like this, where we have a number equals a completely different number, a false statement, this is one of the solutions where the instances where we are not going to have any solution of any kind. These two lines are parallel to one another, and there will be no solution to the system of equations. So we write in for our final answer, no solution. Okay. So again, the no solution instance is when we go through the process, you follow all the steps the exact same, and you get a number equals a different number, which again is a false statement. It's impossible, which tells us from this instance, and we'll get to and take a look at this graphically, tells us we will not have a solution to these two equations. There will be no point where these two things will cross each other, no solution. And then we're done. We can't do anything else from here. Let's take a look at the instance, or our fourth instance, which you guys can probably put together, have a good idea of what this is going to look like, but we'll go through it all the same. So the equations we have been given for our fourth example, we have 2x minus 3y is equal to 12. Then we have negative 12x plus, or negative 12y, I should say. It would help if I write this thing down correctly. Negative 12y plus 8x is equal to 48. It's going to be our first equation, our second equation we have there. So again, we are going to be solving, following our process, solve one of the equations for either variable. So both of these instances, we have not explicitly been given x equals a number, or x equals something, or y equals something. So again, we need to solve one of these equations for one of these variables. Doesn't matter which one we choose, just need to pick one and move forward with it. So for the sake of it, I'm going to choose the first problem. I'm going to solve that first equation for y. So to do that first, I'm going to subtract 2x from both sides. Oops. So if I subtract 2x from both sides, get to that there. And then again, I want y equals, so I divide both sides, meaning every single term, by negative 3. So I'm getting 2/3 x minus 4. Fractions are fine. They are not unheard of to show up in these types of problems. They're fairly normal in that regard. We get our equation that we have here. So now we have y equals a bunch of stuff. And now we're going to substitute that into our second equation for y. It should be noted, I wrote out our process of rewriting this thing or solving it for y horizontally. Whatever you need or want to do to organize this in a way that might work a bit better for you, you are more than welcome to do that. I've seen some people write below the problem, solve equation 1 for y, and then work it out from there. You're welcome to do that also. Whatever works best for you, to tell yourself, what equation am I working with and what variable am I solving for? If you have your own organizational method, do it. Use it, totally fine with that. Just wanted to make that note here and now so you guys are not under the assumption that it's my way or the highway. No, there's plenty of ways to do this. So again, I'm substituting this value that we found here in for our equation, in for equation 2. So again, plugging that value in, I have 2/3 x minus 4. Okay. And now from here, I'm taking this negative 12, it's distributing through to everything inside. So it's going to be, let's see, negative 12 times 2/3. It's going to be negative 24 over 3, so that's going to be negative 8. And then negative 12 times negative 4, that's going to be a positive 48. continue to simplify the left-hand side down. I have negative 8x plus 8x. Those cancel out, and I get 48 is equal to 48. Now this instance where I have a number equals itself, we have here, this is an instance where we are going to have infinite solutions. So we write out for ourselves for our final answer, better infinity. There we go. This means that these two lines that we, or two equations that we started out with, are the exact same thing. And based on that, we are going to have an infinite number of solutions. Meaning if they're the exact same, they're going to lie right on top of one another, and they will intersect or cross each other at every single possible point that they can. Hence where we're getting infinite solutions. So this is how we would go through and we would solve all of these systems of equations algebraically. Move this over here. And again, your organizational method for rewriting each of these equations for one of their variables, whatever works most efficiently for you, go ahead and organize it for yourself that way. I just have developed some habits over the years of writing these out a certain way, and I just stay consistent with those because it makes sense, the most sense to me. But again, there's multiple ways to do this, so find one way that works for you, and then work with that. So we've gone through and we've solved these things algebraically. Now I want to demonstrate and show you guys what this would look like graphically to find a solution. So I'm going to jump us over to, oops, where are we at here? I'm going to jump us over to Chrome here. And I'll show you guys what this looks like, what these look like graphically. Okay. So this is the website Desmos. Very, very handy website, especially for creating and displaying graphs for ourselves. It's a free website. Just look in desmos.com. Just put that in Google. It should be the first option that showed up. The /calculator part you can have in there. You don't necessarily need it in there. But this is the primary one that we are working with, the primary thing you'll see show up. So if we were to go through and actually graph these things out for ourselves, again, to go through the whole process and otherwise, I do want to give us some time to ask questions at the end of class here. So I'm going to go through and use Desmos to display these two things. So what does the visual of our first example pair that we worked with? So that was our first, we're going to type in our first system of equations. So the first one that we had was x plus 3y equals 10. So it's our first thing that's showing up there. It's in green. Our second equation we've been given is 4x plus y is equal to 18. So we have our two graphs that are built out here for ourselves. And here's the really nice part about Desmos. If we were just to inspect this thing and say, all right, well, where's our solution going to be? Looks like it's at 4, 2. We click on one of the lines here, we can see here's the point of intersection, and it truly is at the point 4, 2, which is really handy. So again, where's the solution? It's where these two lines intersect each other, and it's right at this point that we have right here. So this is visually what this is going to look like when we have a solution to a system of equations. It's where these two lines are going to intersect or cross each other. Now we'll take a look at our next system of equations. Number 2, we were given the equation, or the two equations, negative 2x plus y is equal to negative 11. So our first one graphed there. Our second equation is x plus 3y is equal to 9. So again, where do these two lines intersect each other? If they do, it looks like it's right over here. So it's over at, looks like 6 and then 1. We click on one of these lines. What's the point of intersection? It is at 6, 1, which is the same thing that we found algebraically. So our point of intersection is right here. But again, this is what this looks like graphically, where we have a single solution to the system of equations. Looking at example 3, we'll type those ones in. So our first equation for example 3 was 5x minus 2y is equal to negative 10. So our first equation there. Typing in our second equation, we're given y equals 5 over 2. Hitting the right arrow key if you're following along or trying to do this as well. Hit the right arrow key, puts us out front because we want 5 over 2x. And now as we look at this thing, where are they going to intersect? Well, these things look like they're parallel to one another. You can use the mouse wheel and you can actually zoom out. So let's zoom out here a little bit and see what this looks like. So it looks like these are going on and on and on forever, and they just remain parallel to one another. It eventually looks like they cross over, but that's also because we're zooming really far out at this point. So this is what it's going to look like visually when we have two equations or solve things out and we find a number equals a different number. We have two parallel lines that are never going to intersect in any point at all anywhere on this graph. And this is what that visual looks like. And we put these things to a graph. So our final example, this is example 4 now, we're going to type it in. So example 4, we had 2x minus 3y is equal to 12. So our first equations are written there. Our second equation that we were given was negative 12y plus 8x is equal to 18. Oops, did I write that in right? 48, my mistake, is equal to 48. I find that these two things, they lie right on top of one another. So where do these two lines intersect one another? Well, if they're the exact same thing, and one lies right on top of the other one, they're going to intersect or cross each other along the entire span of the graph, which is where we're going to get infinite solutions showing up for this problem. Okay. So this is the visualization of each of our 4 examples that we have been given. Now we could be asked on the homework or we could be asked on the test, again, determine the solution to the system of equations graphically. So you might need to graph these things and then determine that point of where these two things, these two graphs, are going to intersect one another. And just like we saw with our 3 examples, it could be any of those 3 options. It could be they intersect at one spot, they intersect at an infinite number of spots, or they intersect at no spots. And all 3 are potentially on the table. There's nothing wrong with any of those 3 answers. So again, we can have one solution, that's one point. Infinite solutions, which is where one's on top of the other, which is also perfectly valid. Or we can have no solutions because these 2 lines are parallel and they will never intersect each other. So those are the examples that we have. And again, going through each of them being our 2 different chapters that we have. 5.1, working with the graphical method for solving a system of equations. In 5.2, working with the algebraic method for going through and solving the system of equations. And again, this is our first algebraic method, which is the substitution method. We're going to see when we go through 5.3 tomorrow, we are going to have an additional algebraic method that we can use, but this is our first one that has been presented to us and the first one that we're using for now. So this is everything for the 5.1 and 5.2 material. So we'll end our recording here.